Hello, it's Ryan here from RLF Vacuum Cleaners in Lakenheath. In today's video I'm going to talk about one of the electronic things that I've come across recently that I find really fascinating. About a month ago, one of my neighbours gave me a couple of solar lights for me to repair. They were having, one of them was completely dead and one of them was having really reduced runtime. And originally I was looking at them solar lights. They only use a 1.2 volt nickel metal hydride battery cell. And I was thinking, well, how are they boosting the voltage up to around the 3-4 volts that they need to turn LEDs on? And I was thinking they're going to have some sort of complex circuitry in them. But actually, they're really rather basic. And it doesn't matter where you buy your solar lights from, posh shops, not posh shops, pound stores, they all use the same circuitry, just come in a fancy package. So in this video I'm going to explain why they use this circuit and how this circuit works. So what I'm going to do is I'm going to open a couple of these lights up. I actually bought different lights from different places and these all use the same circuitry, and then I'm going to bring in a demonstration rig I made up to explain how they work. Back in one moment. So here we have them all opened up. We'll start off with these two at the end. This one was the bulb lamp, the LEDs. And as you can see on the circuit board, there's absolutely bugger all on there, nothing on the other side. You just have the battery, which gives you your voltage. You have a 4-pin chip, which in this case is a ZX808. There's 5252F. There's 8018 as well. There's loads of these little 4-pin solar charge chips available. So what it is, that's all. That is the circuit board that controls the light. You have a solar panel on the bottom. The solar panel comes in, charges the battery. This little chip here is a boost converter. So what that does, it pulses this inductor to boost the voltage, and then you just have a switch to turn the light on and off. Remarkably simple, and they're all the same. This one's got a switch. This other one here, the solar lawn light, doesn't have a switch. This one is purely basically a 4-pin chip, an inductor going out to an LED and a battery. Then we have this one here, which again is the same 4-pin chip, inductor, switch, battery, solar panel. Now when it starts getting a bit clever is this one here. This one here is the flame effect flashing balls. Now this one again uses a switch, a 4-pin chip, an inductor, but because this is running microcontrollers, they put a couple of diodes, a capacitor and a resistor to try and hold the voltage steady. So when it's oscillating, you get these voltage spikes. This is all smoothed out to give you the flame effect. So yeah, this is all solar lights are. Solar garden lights aren't actually that complicated. Here's a demonstration model that I have built to show people. Now, everything on here is oversized. This is a PCB I picked up offline because I was looking at making some of these little circuit boards, but then I realised that somebody had actually done it better than I could do it, so I just gave them a few pounds towards their contribution and got loads of these circuit boards made up. That is all that was required. You have a solar panel input, usually around 2 volts. You have a input that goes out to your battery, a switch to turn the light on and off, a 4-pin chip, and an inductor which pulses to generate the voltage to drive the LED. And the way this chip works, now there is light on the solar panel. It's telling this chip, this IC here is actually in charging mode. If I cover that up, it notices that the voltage has dropped, which then engages like a little, I'm not quite sure what's inside there. I'm going to say some sort of like transistor or MOSFET, which then turns the inductor on, which then generates the voltage from the battery. Turn the light on. These are remarkably simple, so when it gets dark, light comes on, which is good. But these chips are only good for the 1.2 nickel metal hydride batteries. I've got an Eneloop one here, just for my demonstration one. Now, what if you wanted to drive something at a slightly higher voltage? Well, if you want to run something at a slightly higher voltage, the only other option I've come across, well, there's a couple of different options. This is a disposable vape battery. I'm using this for example, and again, from the same person I got the circuit board from. These people actually do another circuit board for especially designed for these lithium cells. Now I came up with a slightly different design. My design's slightly different to this, but their design works just in the same way. You've got a couple of transistors, TP4056 charge control board, and there's your inputs, and you have your LED, battery and solar. Got your TP4056, which does all your charge control stuff for your battery, and then you have your transistors, resistors and diode. What this is, when the light is on the solar panel, what you're doing is you are pulling transistor to ground, effectively shorting out for a resistor. In fact, I'll draw a diagram actually, it'd be easier to explain on a diagram than this. But then when the solar voltage drops, the transistor then opens, which then allows this other transistor to go, which is across the supply, which turns the LED on. So when you cover the solar panel up like so, which turns the LED on. Now, because we're using transistors and the transistor resistance plays into effect, you effectively have, the more you cover the solar panel, the harder the transistor turns on and the brighter it gets. So you get a lovely, nice fading effect. So if it doesn't come on hard straight away, as the light slowly gets darker, you notice it starts to increase intensity. And it's the same when it's getting light. As it starts getting light, the light dims. Unfortunately, where this is positioned, it never fully go out because it's not in good bright direct sunshine. So yeah, there are a couple of other ways I've seen solar garden lighting doing, but then again, these two methods are the most common I've seen. There are other methods, but then again, they're not quite as cheap and as simple as the two methods I'd shown. And one thing that really surprised me was these little chips here, and these inductors and switches and batteries, and the circuit board. The kit I built this whole entire thing, obviously, battery holder and the battery I had, and the solar panel I was using for another project. But this actual circuit board here, you can actually knock that up in small quantities for about £1. So imagine you start getting mass production scale, how much would it cost to produce these boards? I suspect, because you can buy these chips for about 5 or 6p, the switch is about 5 or 6p, the inductor is about 5 or 6p. Batteries, depending on where you buy them from, they're going to vary in price, but I send them as low as sort of like 50p to £1. And then you've got the LEDs, so even in small quantities, when you're looking at a couple of pounds to build them, obviously start getting to mass production, I reckon you could probably mass produce the whole thing for less than £1, including the actual plastic fitting and the bulbs and everything. So yeah, I hope this video has been some interest. I thought it was jolly interesting. A lot of these small, cheap 1.2 nickel metal hydride solar lights all use the same principle. A 4-pin chip, inductor, a battery, a switch if you're lucky, and a solar panel. And some LEDs. So yeah, thank you very much for watching, and goodbye.